Hello everyone, welcome to the NN classroom. Today I'd like to share with you a specimen question, also extracted from the paper one, which is question number 22. Another extremely classic question asking on topic 16 about the rate law and also the application of rate equation. What is the question talking about? The rate information below was obtained for the following reaction at a constant temperature. So here is the reaction concerning. And what's the question? What is the overall order of the reaction? First of all, what's the meaning of overall order? Supposedly, this technique behind relating to the concept of the rate law. What rate law suggesting that is that rates will always be proportional to all the concentration of reactant correspond to a corresponding power. This power is what we call the rate order, right? The rate order directly relates how the concentration of each reactant to the rate idea. And in your syllabus, this order can only be 0, 1, or 2. So we call it self order, first order, or second order. Right? So in this case, based on the rate law, we first apply and now make it into a rate expression. So rate will be equals to K times or the reactant H2O2 be the first one, that to the power X, and then also to the second one, which is H plus to the power Y, and finally to the iodine, I minus to the power Z, right? And what our task is really obvious. Be able to find out X, Y, and Z. And add them up, that will be what we call the overall order, right? So from this question, the basic technique, the skill for this question is that always look for a pair of experiments. This is also one of the major concepts of how we can deduce the rate order of each of the reactant, or you can say with respect to each reactant, is that as the order can only be deduced from doing experiment but nothing else. So that's why always be the question that give you a set of experiments by changing the different initial concentration and see how changing the concentration of such a reactant will brings an effect to the initial rate. So that's what the skill remember is that every time we just look at a pair of experiment. But how do we choose this pair to be the pair that we are choosing is to try to find one pair in which only one of the concentration is changing, but not the remaining. Otherwise, if two concentrations are both changing, we cannot draw a suitable conclusion of whether the rate changes is due to the effect of this reactant or that reactant. Yeah, if you're clear about that, so first of all, maybe I will label the experiment for you first as 1, 2, 3, and 4. Right? So this is the fourth set of experimental condition, right? So at the very first beginning, which pair I would choose, right? Yeah, if you copy down, so I just mark it, right? The thing is, I would compare experiment 1 versus 2, right? By comparing experiment 1 versus 2, what we get is that the concentration of the H2O2 is being doubled, right? But at the same time, H plus and iodide are not having any concentration change. So that means any of the rate changes must be according to my effect brought by the increase in the concentration of H2O2. So that's why in this case we see that the concentration of H2O2 is being doubled. And this will bring an effect to the rate also be double. So U double, I double, so this is the concept of first order. So that's why in this case, as we labeled the order with respect to H2O2 as X, so in this case, X equals 1, right? So if you notice, that we continue, right? So the next pair that we can choose in order to find out other will be, let's say, experiment 3 and 4. 3 versus 4. Because in this case, if we look at 3 versus 4, concentration of H2O2 doesn't change, concentration of iodide doesn't change, but the concentration of H plus, which is the proton, doubles. And these doubling effect times 2 bring nothing to the rate of reaction, still keep as 5.25. So in this case, meaning that the order with respect to H plus, so that is Y, is going to be 0. And finally, we just break down also iodine, right? So in this case, which experimental pair we choose, that will be experiment 2 versus 3. Because by comparing experiment 2 and 3, we see that H2O2 doesn't change, H plus doesn't change, but the thing that changes is iodide. And the effect is also double. And this doubling effect will also bring the rate to be also double. So that's why from this perspective we can know that the order with respect to iodine, which is Z, is equals to 1. So that's why the overall order is the sum of the individual rate order of all the individual reactants. So that will be overall order 2. So that's why the answer for this case will be C.